Okay, I'm going to try to finish up section 6.1 now. We're talking about systems of linear equations, and we've already looked at the graphing method, the substitution method, and the third one to know in this section is called the elimination method. So we sometimes call the elimination method the addition method. You'll see why here in just a moment, but let's take a look at some examples of this one here. I want to solve this system, and I'm going to use the elimination method. Now, in the elimination method, you want to pick a variable to eliminate. Okay, pick x or y and plan to get rid of that in the problem. So let's get rid of x here in this one. To get rid of x, I'm going to multiply the bottom equation by 2 on both sides, and then I'm going to add the equations together. Okay, I'll leave the top equation as is. And like I said, I'm going to multiply the bottom one by 2 on both sides. I've done that here. When I distribute the 2, I'm looking at negative 2x plus 2y equal negative 6. Okay, now I'm going to add these together. And by adding the like terms, 2x minus 2x is 0, so x is eliminated. 3y plus 2y is 5y, and then 1 minus 6 is negative 5. 5y equal negative 5 means that y is negative 1 when you divide both sides by 5. Knowing that y is negative 1, we can then plug that number into either one of these two equations. It doesn't matter which equation we select because y equal negative 1 has to satisfy both. So let's just plug that into the bottom equation here. Negative x minus 1 equal negative 3. If you add 1 to both sides and then multiply by negative 1, x would be 2. So I think x is 2 and y is negative 1 here. Let me check that. Is it true that 4 minus 3 is 1? Yes. And is it also true that negative 2 minus 1 is negative 3? Yes. So x equal 2, y equal negative 1 is correct. Okay, now, so you can see why we would call this the addition method. We're adding the equations together, the like terms. Now, if I wanted to eliminate y, that would have been fine. I would have found x first and then got y second. I would have still got the same answer there if everything was done correctly. But in order to eliminate y, I would want to multiply both sides of the bottom equation by negative 3. So then when I add 3y minus 3y, that'd be 0, so y would be eliminated. Okay, here's another example. Now, sometimes you got to work with both equations in order to eliminate a variable. Okay, like in this one, let's try to eliminate x again. If I multiply the top equation by 3 on both sides and then the bottom equation by negative 2 on both sides, then here would be those resulting equations. So then when I add them together, 6x minus 6x is 0, negative 21y minus 8y is negative 29y, 69 plus 76 would be 145. If you divide both sides by negative 29, you'd get y equal negative 5. So then if you plug negative 5 into either one of these two equations, I'd plug it in the top one here. 2x plus 35 equal 23 if you subtract 35 from both sides. And then divide by 2, it looks like x is negative 6. So x is negative 6 and y is negative 5 would be the solution to that equation, to that system rather. Okay, here's another one. Let's eliminate x in this one. Okay, so if I multiply the top equation by negative 2, and then I'll leave the bottom one as is. Multiply the top equation by 2 on negative 2 on both sides, and add the like terms here. Negative 4x plus 4x is 0, so x was eliminated. That's what I wanted. Negative 2y plus 2y is also 0. And then negative 10 plus 8 is negative 2. So I'm getting 0 equal negative 2. Of course, that's not a true statement. So, but both the variables were eliminated here, and you're getting something that's not true. Of course, that would mean that you're working with an inconsistent system. There are no solutions to this system here. Okay, and here's another one. Again, we're using the elimination method. We'll eliminate x. So to eliminate x, multiply the top equation by 5 and the bottom equation by 2. So then here's what I got when I simplify both of those. Now when I add these together, negative 10x plus 10x is 0. X is eliminated. That looks good. That's what I wanted. And then 30y minus 30y is 0. So y is actually eliminated also. 50 minus 50 is 0. Okay, so I get 0 equals 0. And of course that is not news to me. I already know that 0 equals 0, but this is a true statement though, you know, unlike what we were getting up here. 0 equals 0 is true. And in this situation there would be infinitely many solutions then, since you're always going to get, you know, 0 equals 0, that's a true statement. That's a dependent system. Okay, so my answer, written as an ordered pair x, y, if everything is in terms of x, take the top equation here and solve for y. If you add 2x to both sides and then divide by 6, I'm getting y equal 1/3 x plus 5/3, and so I've written that in the y coordinate position. And you know, this would be one way to describe to somebody how there'd be infinitely many solutions to the system. If you give me any x value, I can always come up with a corresponding y value by taking 1/3 times that number and then adding 5/3. So I can generate infinitely many points that would be on these two lines here. Okay, and I've got here'd be the homework problems in this section. Just before we look at that though, I also had some applications. This was another sheet that was on the on Blackboard there. This was actually still part of section 6.1. So why don't we take a look at some of these. Now that we've talked about some methods for solving, we want to look at some applications. Now, if they're not telling you the method to use, you know, of course you can use any method. Doesn't matter what method you use. If everything is done correctly, you should still get the same answer. Okay, but I would say, you know, try to avoid using the graphing method if possible, because I commented on the fact that sometimes you might have values that are not, you know, nice looking numbers, and so that would kind of defeat the purpose of making a graph if it's really hard to tell where the point is located. So, you know, in general, if we're given the option to use whatever method we want, usually we'd consider using either the substitution method or the elimination method. So let's take a look at some applications now. Problem 1, Ross and Carolyn combined their DVD collection when they got married. Ross had 42 more DVDs than Carolyn had, and together they have 148 DVDs. How many DVDs did each person have? Okay, well, if I let R represent the number of DVDs that Ross had and C represent the number of DVDs that Carolyn had, then I can create this system of equations representing the situation here. It says together they had 148 DVDs. So if I take the number in Ross's collection and add the number in Carolyn's collection, I'm going to have 148 total there. That'd be one of the equations. It also said that Ross had 42 more DVDs than Carolyn had. Okay, so whatever Ross's total is, you're going to add 42 to Carolyn's total to get that total that Ross had. So here'd be my equation representing that sentence there. And here'd be the system of equations that I would need to solve. Okay. Again, any method is fine. Just the fact that this top equation has already been solved for R means that maybe we could use the substitution method here. If we substitute C plus 42 into the bottom equation where we see R, then everything is in terms of C. And I can get C first. C plus C is 2C, subtract 42 from both sides, and then divide by 2. I'm getting C equal 53. Knowing that C is 53 means that Carolyn had 53 DVDs. Now Ross had 42 more than that, so he would have had 95 DVDs then. Okay, problem 2. One group of people purchased 10 hot dogs and 5 soft drinks at a cost of $35. A second group bought 7 hot dogs and 4 soft drinks at a cost of $25.25. What is the cost of a single hot dog and what is the cost of a single soft drink? Okay. I'm going to let X represent the cost of a hot dog and Y represent the cost of a soft drink. So now I'm going to form two equations here, and each equation is going to represent what they're telling me about each of these two groups. So one group of people bought 10 hot dogs and 5 soft drinks at a cost of $35. Well, you're going to purchase 10 hot dogs at a cost of X dollars per hot dog, and whatever that total is, then you're going to buy 5 soft drinks at a cost of Y dollars per soft drink, and that grand total then from group 1 was $35. A second group bought 7 hot dogs at a cost of X dollars per hot dog, and then 4 soft drinks at a cost of Y dollars per hot dog, and they paid $25.25. So these would be my two equations representing the situation here, and both these are cost equations, and I would then solve the system. Okay, and it looks like I'm using the elimination method here on this one. I'm going to eliminate Y, and to do that I'm going to multiply the top equation by 4 and the bottom equation by -5 in order to eliminate Y. Here'd be the two equations in simplified form after you distribute. So here's 20y minus 20y is 0. Y is eliminated. That looks good. That's what I wanted. 40x minus 35x is 5x on the left. And then if you take 140 minus 126.25, you should be getting 13.75 on the right. Divide by 5 on both sides, and you're looking at x equal $2.75. That would be the cost of a single hot dog. Knowing that cost means that I can find Y by plugging that number into either one of these equations. I've chosen the top equation here. 10 times 2.725, slide the decimal point over to the right one spot. That'd be 27.5. If you subtract 27.5 from both sides, 35 minus 27.5 is 7.5. Okay, and then divide by 5 on both sides, and getting Y equal $1.50. So that would be the cost of a single soft drink. Now these prices here are, pretty reasonable, normal prices that would be at, most events. And of course, like any other story problem, you want to make sure that your answers are reasonable. We wouldn't want like wildly high dollar amounts or negative numbers or something like that. I do see strange numbers like that. Okay, but and of course, make sure that the answers at least sound right. Okay, here they at least sound right. Of course, they are. These are correct though. Let's take a look. Problem 3 is the last one here on the sheet. Tina needs 302 inches of fabric to use as binding around a rectangular quilt that she is making. The width of the quilt is 10 inches less than the length of the quilt. Find the dimensions of the quilt. Okay, I'll let L be the length and W be the width. The 302 inches wrapping around the quilt would be the perimeter. Okay, and the fact that I'm using a rectangle here, a rectangular quilt, means that I want to take twice the width plus twice the length to get that total. Okay, so 2W plus 2L equal 302 would be my first equation, okay, the perimeter. And it says the width of the quilt is 10 inches less than the length of the quilt. All right, so whatever the width is, I'm going to want 10 inches less than the length to get that number. W would be equal to L minus 10 would be my second equation. Okay, and so now I solve the system here. I'm using the substitution method. Since the bottom equation has already been solved for W, you can substitute that in the top equation. Let's see, so I've done that. And if I distribute 2 there into the terms and then divide by 4, it looks like L is equal to 80.5 inches, and then the width would be 10 inches less than that. So the width is 70.5 inches. Okay. Here's the homework in section 6.1. Be sure to look at those problems that are on page 517 for me.